Hi, everyone. My name is Amanda Milberg. I'm a senior partner sales engineer from Dataiku, and today we're going to be talking about operationalizing large language models. And there's a chance that some of you on the call might be feeling a little bit overwhelmed. LLM ops seems a bit like an overwhelming problem, a little bit of the wild, wild west. And while we know it's something that we need to do, we don't exactly know where to start. But as Albert Einstein once said, the way to solve a complex problem is to break it down into simpler parts. And what if I told you that we already have a lot of these parts that we need to solve this problem, operationalizing an LLM, that already exist in Dataiku today? In other words, we have all of the parts, we just really need to put them together. And so that's what we're going to talk about today. We're going to discuss how to operationalize a large language model. And we're going to discuss a use case and common challenges faced when trying to deploy a generative AI application into production. And we're going to walk through a use case that I worked on myself, developing an internal chatbot for our go-to-market teams to use to find answers to help our customers answer questions about Dataiku. And I'll walk through the final project in detail, what you see on the screen now, and showing how we use Dataiku to ensure we deployed this project in a safe and governed way, adding monitoring mechanisms for performance and cost control, toxicity of the generated output, and human in the loop review. But before we get into this final end state, let's first talk about what Dataiku is. So the easiest way that I describe Dataiku is we're a platform for all of your people, all of your data, and any analytical technique. And essentially, we're an analytics workbench or orchestration platform that allows you to scale data and AI initiatives for all of your people, meaning we're a collaborative platform that unites all user types, so those low code, no code, or full code users, all of your data, in that we have over 25 data source connections and the ability to be deployed on any of the major cloud providers, and any analytic technique, and that our platform assists in the full analytics lifecycle, from connecting to data in different data storage layers to wrangling that data, modeling, ML ops, and of course, LLM ops. And so today, while we will talk about large language models, because how could we not, this platform can be used for any analytical technique. So now that we have a basic understanding of what is Dataiku, let's go back to talking about that illustrative use case. So for folks on the call who might have developed some POC around generative AI, I would assume that your high-level architecture in your design phase looked something like what we have on the screen here. Companies often choose to start these proof of concepts using an LLM API to start their development. They develop a lightweight LLM pipeline that may consist on some text preprocessing, prompt engineering, maybe a development of a retrieval augmented generation or RAG framework, and get some generated text from this LLM that they're using. They then surface the generated text as some sort of data product, maybe a question answering web app, a chatbot, or even a model as an API service. And this is a great way to start. It's how I started too. I created this quick, minimal, viable product, and I shared it with the project stakeholders. And after we shared this with the project stakeholders, we immediately got some feedback of how can we enforce standards to deploy this generative AI application in a safe and reliable way. So to start, the VP of Customer Ops requested that we have some sort of human in the loop validation. If we're going to use this LLM to generate some answers, let's make sure that those answers are validated by our customer success managers before we go and share it with our customers. Our second stakeholder, our head of risk, requests that there's some automated content detection layer built into our pipeline to reject, redact, or hash PII information submitted to those LLMs, and add a toxicity detection to our generated output. And finally, our director of IT wanted to ensure that we have a dashboard for teams to monitor that performance and forecast costs, and automate alerting systems to send message to our teams when our API costs exceed a threshold. And after talking to the stakeholders, I quickly learned that that initial pipeline that I developed wasn't going to fly. And while the pipeline was functional, it's not going to be an application that we can deploy at scale. So given those requirements from our stakeholders, let's suggest a few ways to augment this pipeline. First, how can we employ a safe gateway to ensure that we have choice and agility to switch LLM providers as new technologies emerge, either through different LLM API providers or potentially even switching from API providers to on-prem or local LLMs? Second, how can we evaluate each request that comes in to see if there is sensitive information or PII detection prior to sending the request to the LLM? Also, how could we provide some sort of caching functionality if the same prompts or questions are asked multiple times? How can we use a cache instead of reprompting the LLM service to control some sort of cost? On the generated output, how can we check and monitor toxic responses, raise alerts to our development team to take appropriate action? And finally, how can we monitor the performance of the LLM services across this project and then multiple projects to come? And as these requirements took shape, I thought about also how they might change in the future, proving that in order for this use case and additional use cases to come to truly succeed, we must have a layer to decouple the application from the AI services. We need a reference architecture to follow for not only this use case, but hundreds of Gen AI use cases to come that we plan to deploy in the future. And for that, Dataiku has the concept of the LLM mesh. And your LLM mesh is your common backbone for all of your generative AI applications. Essentially, you can think of the LLM mesh as the middle layer between your infrastructure and your applications or data projects. That's really where Dataiku thrives, as I mentioned before, as that orchestrator or workbench for all of your analytics capabilities. And so the LLM mesh consists of core components, many of which follow those requests that our key stakeholders were talking about. It puts the control of AI resources back in the hands of analytics and IT leaders so they can effectively manage this transformation technology, safety, performance, and cost. So now that we understand a little bit about our project stakeholders, let's deep dive into the Dataiku project flow. What you see on the screen is a Dataiku project flow. It's a visual representation of how the data is moving and transforming from left to right. Blue boxes represent data sets. Orange circles represent code recipes. Yellow circles represent visual recipes. And the pink circles represent where we're using large language models in our flow. And this is now what my production flow looks like. And so I'll walk through each of these concepts to show how we've added functionalities that our stakeholders requested and use components of the LLM mesh to make sure that we're deploying this in a safe and governed way. First, we'll show how we can utilize built-in text analysis recipes to add business knowledge to our LLM with a RAG approach. We'll also show how we can leverage prompt studios to track and compare various prompts and experiments across different large language model providers. We'll show how we can leverage the labeling recipe to provide human-in-the-loop validation to our generated output to make sure that we're not sharing anything with our customers that we do not approve as an organization first. We'll also add PII detection using natural entity recognition, or NER, to detect PII in our input data sources and then filter them so they're not being sent to our large language model. We'll write custom code in a code recipe to use open source technology to run toxicity scores over generated content. We'll then add metrics and checks in Dataiku to alert the user if this toxicity check fails. We'll also show how we use the logs captured in Dataiku as a caching layer to avoid unnecessary regeneration, and then instead provide previously validated results to control cost. And then finally, we'll show how we can use those logs to monitor cost and raise additional alerts with metrics, checks, and scenarios. So let's take a look how we build out that retrieval augmented generation pipeline. The LLM managed connections and different text analysis recipes allow us to rapidly prototype generative AI applications in Dataiku. Let's take a look. First, we start by moving this unstructured data to structured data with a plugin. After, we use an embed recipe to build a vector store with our internal knowledge. Now we can add various text analysis recipes on top of this input, such as the prompt recipe. You can see here how we can toggle between one LLM provider and another, as well as using our retrieval augmented LLMs. We can also edit these prompts in a prompt studio. Now let's talk how we can do some content moderation to flag input queries that have sensitive information and monitor the generated toxic content and validate with human-in-the-loop review. We want to plan now for the inevitable standards of the future, ensuring that these applications ensure operation, legal, and regulatory compliance. So to start, on our input queries, we can use natural entity recognition, or NER, to detect PII in a code recipe. If this PII is detected, we can filter those queries out using a filter recipe as to not send it to the LLM. On our output data set, we can use another code recipe to generate toxicity scores across different categories. We can then add metrics and checks to ensure checks are passed before sharing this with our downstream users. Finally, as a human-in-the-loop review, we can use our labeling tool to annotate whether these responses are correct or incorrect. With these annotations and second-level reviews, we'll now have a structured data set, which we can use for the caching mechanism or also to retrain the model as necessary. So now let's look a little bit deeper in that caching and cost control, how we can log queries to avoid unnecessary regeneration. So if we look at our pipeline, how can we enable caching to optimize performance and cost controls? Essentially, we want to avoid recalling LLM services for the same information. So let's remember our use case. Our customer success managers are putting in questions from our customers about Dataiku. In this example, we can assume that multiple customers would have similar questions. In that case, if we log all of the questions asked from the LLM previously, we can then add a caching layer to semantically search that audit log, apply business logic, and then return the cache-generated answer instead of recruiting the LLM. This would allow us to control cost. So let's see how that looks like in Dataiku. So in Dataiku, all activities are logged, including information like the LLM answer of the past, as well as that positive and negative feedback we got from the labeling recipe. We can then add something like a semantic cache using a code recipe to first see which questions we can use a cached answer for. We can then filter out those cached questions and only ask the new questions to the LLM provider, ultimately saving costs. The last aspect that we're going to talk about is doing performance and cost monitoring. And this is important because we want to make sure that using a large language model or our investment of using generative AI gives us a return on that investment. And the reason why doing performance monitoring on large language models is so difficult is because LLMs are non-deterministic in nature. This means that if I ask the LLM the same question 3 times, it could give us a different answer. And that doesn't mean that answer is wrong. If I ask 3 people on this call what Dataiku is, I'm sure you all would give me a little slight variation of a similar answer based on your understanding. But those are all correct. And that's exactly how LLMs work as well. And so what's difficult about this non-deterministic nature is that as opposed to the quantitative approaches that we use for traditional machine learning models like regression or classification, we can't use those quantitative approach or those scores that we usually use to evaluate models, such as precision, recall, F1 scores, etc. And so instead, we propose this qualitative approach of looking at a matrix of different components, such as latency, cost, bias, or coherence, to evaluate if this LLM model is performant. And so what I'll show you is how we can do that in Dataiku using those logs again to provide all of this information on some sort of a dashboard for then our downstream business users to run, again, metrics or checks to ensure that these models are passing the necessary gates before moving it to production. And so let's see how we can use that in Dataiku to monitor both at a project level and an instance level how we can define this performance and cost monitoring. So as I mentioned before, everything in Dataiku, every action is logged via the LLM mesh. So this means that I can look at a data set and get information like who called which LLM, what the estimated cost was, which provider did they use. And I can also add metrics and checks over, for example, if toxicity is detected. I can also look at things on an instance level to get an idea across different projects, what the cumulative cost is, what the cost is by user, or even things like the daily or hourly cost. Finally, I can add alerts. So if different cost metrics are achieved, I can send something like a Slack message to alert my team that we have exceeded the daily LLM threshold set by our administrator. So hopefully these examples have shown you how you can use something like Dataiku to operationalize your large language models. And as I mentioned before, we had the pieces, we just needed to put them together. So components or techniques that we saw, such as using metrics and checks, compute resource usage logs or logging, code recipes to extend beyond the capabilities that exist in Dataiku today, dashboards and web apps, as well as scenarios to send that automated reporting, has shown that we've now stitched together all of the pieces we need to deploy these generative AI applications in a safe, secure, and governed way. So thank you. I will now take some questions if you have.
Hi, everyone. If you have any questions and you'd like to post them under the Q&A tab, I can answer them one by one. I see that there's one question in the chat already, but yeah, as I go through and answer some of these questions, feel free to add some. So the first question is a question about how the cost is a metric for quality and accuracy. And I think what we're trying to explain is that in this concept of evaluating LLMs, we don't have an exact metric for accuracy at the moment right now. And so instead, if we can take more of a qualitative approach and create our own matrix of things like cost or reliability and coherence, because that's what would matter to like that IT stakeholder that we were talking about. And so they might choose to move something to production if the cost is beneficial. And so that's the idea really in the qualitative approach. Until there becomes metrics like the equivalent of an F1 score, precision or recall, maybe we can create your own metrics that are work for what's important to your organization to evaluate, the good and the bad of these LLM outputs. So that was the idea. I do agree that there are some cases where that might not be relevant to a certain person, but thinking about different personas here. Okay, so do you have any tips for getting inference time from the LLM as low as possible? So I think, one question here is latency. Two quick things that come to mind. It depends on what your pipeline looks like. So for example, if you follow something like a retrieval augmented generation or RAG pipeline, that really involves two steps. So that first is querying a vector database for similar answers and then using those answers in the prompt to the LLM to generate a response. So for one example, if you're using that RAG approach, depending on your underlying vector database that you're using as storage, it's going to change again across different providers. So some examples is like Face, the one that we use in this example, versus a Chroma or Pinecone. So you'll see different latency in terms of how that's returned. Maybe that's one of the first things to toggle. Another idea is how you stream the response. So for example, if you're using something like a web application, you'll see when you interact with the browser-based ChatGPT, it streams the response. That means that as soon as it has a generated answer, it returns back those words or those questions. And that perceives like it's answering quicker than it possibly is, because as it's continuing to generate, it will start printing the response. So I've worked with customers who add this, it's called streaming mechanism, into the response in that chatbot web-like interface to make it feel like that inference time is maybe a little lower or a little bit more instantaneous. So definitely things that you can do in the UI to make it think that it's thinking. Also, that caching mechanism is a great way, because if you have answers that have been, or questions that have been answered before in the cache, you can just submit that cache response instead of regenerating the large language model. And so in that case, you'll have a really low latency by first just doing a similarity search over the cache and then submitting that, which may help. So definitely a few techniques that you can do to get that inference time as low as possible. Those are some that I would start with. Any other questions or comments? Feel free to post those in the Q&A or the chat. I know there's a lot of questions about the webinar and the copy of the recording and the slides, and that will be shared. Oh, thanks, Miriam. Okay, so one of the question is, what is a substitute for accuracy at the moment? And so I think this is a really good question. I'll answer to the best of my knowledge of what I'm aware of. Um, I know that there are some open source technologies that help in evaluating LLMs. For example, there's things such as RAGAS, RAGAS, that's helpful for evaluating RAG. It depends on kind of what your pipeline looks like and if you have a ground truth available. So, for example, if you do have a ground truth available, meaning you have the questions and the answers of the past, you could do something like compare those two using a similarity score. And, if that's comparable in an automated fashion, you could give that a 1 or a 0 and compute something like an accuracy. It really depends if you have that ground truth available. There are certain papers that talk about querying, an LLM a few times and then comparing the generated response of one to the other to see if it's similar. Different approaches. I think we haven't seen one emerge as you know, the right metric in this situation, like we have in terms of the more deterministic approaches of machine learning. But I would look into RAGAS, RAGAS. And I agree. F1 is not the best measure to accuracy on LLMs because, like we said, it's non-deterministic. And that's what makes those traditional approaches difficult to apply. So I do feel like we'll see something come through like how we apply other, scores on other natural language type things. But definitely to come. As we know, this is a very innovative field. Okay. Did your organization have difficulty facilitating amongst various departments? For example, IT, automation, telecom. We definitely see that across different industries, there are different security governance requirements, different things that people want or need, more regulated, more not. Luckily, the LLM mesh, I think, takes a lot of that into consideration. So people are responding well to things like PII detection, or even just having that gateway that we spoke about to be able to ensure that API keys are not flying around in specific notebooks, and there's a platform that people are working on with per user credentials and stuff like that. So there's definitely different requirements that are faced across industries, but as an organization at Dataiku, we make sure that we satisfy those requirements in each industry. So we'll see some folks, opting for the LLM SaaS providers. We'll see some folks that are opting for locally hosted LLMs. If that's what they require, they don't want to send the data out. And with the LLM mesh, you can connect to both. So I would say that we're pretty flexible in dealing with the different requirements of different organizations. Ken asked, how frequently do LLMs need to be updated? I think, again, this depends on your business case. So, for example, again, in our example, if we're building something like this RAG pipeline that was done on our internal documentation, I would say we release new versions every 6 weeks. So probably every 6 weeks, we'd want to update with the latest and greatest from our documentation. So I would ask questions like, is my underlying data, has that changed? Or incorporating some of the feedback mechanisms that we showed in this example to say, hey, our feedback score is dropping because we have that positive or negative feedback from humans as they're responding and interacting with that chatbot. Maybe it's time to revisit our LLM, tweak our prompt, or add new documents to our vector database. So I would say there's not a perfect equation of how frequently do the LLMs need to be updated, but having a good monitoring or feedback mechanism in place can help provide some guidance on when this should be updated. And in the example of in Dataiku, you can track all those metrics or drift, I would say, to say something like, if that metric has fallen, trigger a update of this pipeline, or even just sending an email to the development team to making them aware. Okay. Are there ways to use this for tokenomics of a community for crypto or trading of crypto. To be honest, I'm not super aware of that concept, so I would have to look into it a little bit more. I will say LLMs are really great with working with unstructured data. So think of examples of when you want to ask questions over long and lengthy documents. That's this example that we're showing, the RAG example, retrieval augmented generation. So, using something where you have long, lengthy documents that you might be doing something like a control F to search through to find the answer. That's where we're seeing a lot of benefits of using LLMs. So yeah, I would have to look into more exactly what that means. I'm not as familiar in crypto, but maybe start there with asking yourself, what kind of data or what do I want to ask questions on? Okay. What are the greatest challenges you face in this process? I think one challenge is as folks are interacting with the LLMs or as this is being rolled out to production, providing some good documentation to enable the user of how they're supposed to interact, how they're supposed to interpret these answers is helpful. So for example, in a chatbot, providing a few example questions of like what that prompt should look like as you're asking the LLM, what expected results you get back, and what kinds of questions this LLM should be capable of answering or not. I think one challenge is just, setting the expectations of this technology, because while LLMs are powerful, they won't be able to answer everything correctly 100% of the time. And that's usually due to the information that we've given in that, vector database or in the prompt that we're creating. So I do think it's important to enable your user groups and the expectations of like what this LLM can do before rolling it out. And then if you're starting conversations about just using generative AI in your organization, it's just important to set those expectations generally of what LLMs are great for and what LLMs might not be a perfect fit for at the moment right now. Because we're definitely seeing, it's game changing in terms of how it will affect our day-to-day work. But definitely, making sure that there's not disillusionment is important. And what I face a lot when just educating and coaching or advising customers on using generative AI in their day-to-day business work. Okay. Any suggestions on how to create a high quality vector database from PDF files? There's definitely, every vector database is pretty much taking in some sort of unstructured data. So whether that's in the form of a PDF, a docx file, I don't know, I'm blanking on other unstructured data sources right now. It will do the technique or the idea of creating a vector database is turning that text into a vector, which is a numerical representation of the text. So, a lot of those different databases that I recommended or that I explained, like Face or Chroma DB or Pinecone, all have a little bit of their own proprietary methods of embedding that and then searching it. I've personally, experimented the most with Face. What's nice about it is you can save it locally. You don't have to get something that's a third-party service. And I think it works well for like a small quality of documents and just testing out. But if you go on, for example, like LangChain's documentation, you'll see a bunch of different vector stores. And there probably are positive and negatives of using different ones. I don't know all of those nuances, but I think if you have, less than 1,000, 2,000 documents, I think a Face is a great place to start. And in a lot of these situations, just starting with something is good. You can continue to augment and improve. But I agree that starting somewhere is good. Okay. What methods would you suggest to capture a toxicity score? Again, I've played around with only a few. The one that I used is Toxic BERT. So it's a Hugging Face model that's available to bring into your pipeline via the Transformers package in Hugging Face. That one is pretty good. So it essentially reads your input text and then it scores across, you saw it maybe in the video, across 8 categories or 5 categories against different topics. And so then, on understanding that toxicity score against different topics, you can add some rules to understanding, is this good or bad, or do I not want to send something that has even a slight amount of toxicity? So that one's nice because it's like Hugging Face, it's free. There are other toxicity or moderation endpoints that are provided by LLM providers like OpenAI. That one's good as well, but it is, there is a cost associated with hitting that API endpoint versus using something like Toxic Burp or Hugging Face. I'm sure there's other stuff out there, but that's maybe where I would start. Yeah, so it's Pinecone, Face, and Chroma DB. I just posted it in the chat. And for those of you who are using Dataiku or something like that, those are the 3 connections that we have available as part of the LLM mesh, probably why I'm partial to them. But also just with talking to customers, definitely the ones that I hear come up the most. And definitely, I've heard of Milvis. I don't know if I'm pronouncing that one as well. I haven't personally messed around with it, but it's come up. But like I said, just what I've been familiar with, I'm sure there's a lot of great stuff out there. Okay, next question. With all of these NLP and LLMs, will there need to be structured data in the future, or would access to only the raw data be required? This is a really good question. I like it because we've been talking a lot of using LLMs for unstructured data in the use case that we presented today. But there's also a lot of use of using LLMs on structured data as well. So something that you might have heard is called natural language querying. Essentially, you can write what you want in natural language, like show me the average of sales by state. The LLM will convert that natural language to a SQL query and then execute it against structured data to give you back a result. So there's definitely a ton of use cases using LLMs over structured data sources as well. And I think that could be really beneficial for more business analysts or non-technical people who don't know how to write SQL, as an example, be able to analyze or ask questions over their data sources. Or the example that we hear coming up a lot is like in a report, such as some BI reporting tool, like a Power BI, Tableau kind of thing. How can you, and I'm pretty sure these already have capabilities like this, how can you, ask questions over those charts and structured data that you see. And, generative AI is just another aspect of, machine learning or artificial intelligence. And in machine learning, models love structured data source. And so I don't think that concept of, running predictions and regressions and stuff like that is going away. If anything, we see the two combined being super powerful. And so I can give you an example. We use, a normal forecasting model to forecast sales over the next 12 months. And then we use generative AI to summarize that forecast, generate an email to send to our sales teams or something like that. So I think the combination of both is helpful. And I don't think a world where we go back to like totally raw data, because essentially we're taking this raw unstructured data and we're turning into some sort of structured data source to do the querying against. So it'll be interesting to see. Maybe I'll be, wrong. But I definitely, even though we spoke a lot about querying off structured data, unstructured data today, there is a lot of cool generative AI stuff around structured data and natural language querying, which is definitely interesting to look at, and I've seen come up in customers that I've spoken to as well. All right, a lot of good questions. Nice. I haven't really messed around with structured data to use RAG system, but it's good to know that it works the same. And I think further just, has the point of, structured data isn't going anywhere. All right, any other questions? Still have some time, so happy to answer them. Okay, is there a free trial of the Dataiku platform available? Yes, I can post it in the chat. But yeah, you can create a free trial of Dataiku and kind of play around. And then if you have any questions, there's probably a way to get in contact with someone. But I posted in the chat how to get started. And in the follow-up material, I'm sure there'll be some information about this, so you can find that information. Oh, thank you, Anna, for answering that. Okay. For question answering applications for legal documents, which LLMs would you consider more suitable, and would you opt for locally hosted or not? I think, this goes into the question on governance and security. We'll say at a high level, there's two types of LLMs. There's the ones provided by the APIs, that service providers like your OpenAI, your AWS, your Azure, your GCP, et cetera. Others, players in the field as well. And then you have the locally hosted LLMs. Definitely, if you have private documents that you don't want to share, the privacy statements of these LLM providers say they don't keep the information for data training, but I'll leave that up to you and your security teams. What we see in the field is if people want to, in regulated environments, or are opting for those locally hosted LLMs, there's definitely a ton of benefits of doing that. The initial trade-off, right, is like you have to get, you have to configure it, install it, et cetera, versus just connecting to an API. But there's a lot of cool companies out there that are trying to level the playing field. One, just because I see she's on, is called Titan ML. Super interesting. We've been working with them. That kind of is supposed to make locally hosted models as easy to use as APIs, but they are contained on your own infrastructure. So definitely check them out. But I would say, just from experience, when the first question that I hear is like, this is highly sensitive data, just in general, people are less inclined to use third-party providers, and the API services are third-party providers. So definitely trade-offs, but in that case, it probably makes sense to use a locally hosted one. But there are companies out there that are making that process easier, just because it does revolve a little bit of technical experience. And the next question in the chat is, can we use the latest version of Data Science Studio? Yes. All of these features that I spoke about, the LLM mesh, came out in 12.4 free 3. We're now on 12.5, so we're just continuing to iterate and add more components. If you want to, you'll find everything that I showed today in 12.3. So it's all available plus more today. All right. Well, with that, we'll try to wrap up. Thank you for your engagement. Thank you for your questions. I'm happy that it seems like y'all found this informative. Like I said, if there's any additional questions, you'll be getting a follow-up email. You can, contact anyone at Dataiku. They can point you to me. But thank you for your time and have a lovely day.